Hi guys, Mrs. A here. Today we're looking at solving rational equations. So we see this is a rational equation because we have some polynomials divided by polynomials in the equation. So the goal is to change this to a polynomial equation using a little algebra because we know how to solve those rather easily now because we've done it a lot. So the first thing we want to do is to make note of our restrictions on the variable x here. That means the values of x that are going to make the denominators equal to 0 because we know at those values the domain is undefined. So we have to find the values of x that make these denominators equal to 0. It's always easier to do that if you factor the denominator. So here we have a difference of squares, we can factor that, and then this of course can't be factored. So if we rewrite this as x plus x squared minus 5 over x minus 1 times x plus 1 equals x squared plus x plus 2 over x plus 1. Now we can clearly see what our restrictions on the variable are going to be. So we know that x can't be equal to positive or negative 1. Okay, those would be our vertical asymptotes. So we can't have those in the solution set. So when we come up with our solution at the end, we do have to come back and compare the solutions with these restrictions, make sure that they don't overlap. So now we're going to continue by getting rid of the denominators here. We do that by multiplying every term in the equation by the lowest common denominator that we have. And so that way we get rid of these denominators and turn this equation into a polynomial equation. So our lowest common denominator, I'm going to write it here, we have to look at all of the factors that exist in the denominators. So here the denominator is 1, we're not going to worry about that. For this one, the denominator is x minus 1 times x plus 1. So we know we need to have an x minus 1 factor and an x plus 1 factor in the lowest common denominator. And then here in this denominator we have an x plus 1, but that factor already exists in the lowest common denominator that we're coming up with. So we're not going to rewrite it again. That'll create more work for us in the end. We want to stick with the lowest common denominator. So this is going to be what we multiply the whole equation by to cancel out those denominators. So we're going to multiply every term by the x minus 1 times x plus 1. Make sure we do it on every term because in order to keep that equation balanced, we have to make sure we do it to every single term, even the one on the other side of the equal sign. Alright, now we can look at which factors cancel here. In the first term, there's no denominator, so there won't be any canceling here when we do this multiplication. But in the second term, we're multiplying by x minus 1 times x plus 1, and then we're dividing by x minus 1 times x plus 1. So these all cancel out, and we end up with just that numerator left. And over on the other side of the equal sign, when we multiply by x minus 1 times x plus 1, and then divide by x plus 1, these cancel, and we end up only multiplying this numerator by x minus 1. So now we can go ahead and do all of the multiplication. So this will be x times x minus 1 times x plus 1. And then in the second term we were left with only that denominator, so that's x squared minus 5 equals, on the other side we had this numerator, x squared plus x plus 2 times the x minus 1. And so now you see that we've successfully turned our rational equation into a polynomial equation, and we know how to solve these now. So we're going to distribute everything and collect like terms so that we can end up with a quadratic, actually we'll have a cubic function here that we can solve. So we'll distribute everything. I'm going to start by distributing the x minus 1 times the x plus 1 because I know that was my difference of squares. So that's easy to distribute like this. And then I still have x squared minus 5. And on this side, I'm going to make sure that I distribute here every term here has to be multiplied with each of the terms here. So it will look like this. We multiply this way, so all of those terms, and then we do it again with the -1. So that's one way you can look at it. Make sure that all of your terms are distributed with one another. So here this is going to be x cubed plus x squared plus 2x, and then minus x squared minus x minus 2. Okay, so let's go back and finish the distribution right here. We'll get x cubed minus x plus x squared minus 5 equals x cubed. On this side I'm going to combine some like terms already while we're here. So the x squareds we can put together and the x terms we can put together. Then there's an x cubed left and a -2 left on its own. So here, if I do x squared minus x squared, these end up canceling. And if I do 2x minus x, I get plus x and then -2. Okay, so let's take a look at what we have left. If we combine all of the terms on one side of the equal sign, you'll see that we have an x cubed here, and then we'll subtract the x cubed, so these end up canceling. And I have a minus x, okay, so here I have a x squared term, so that one's going to stay because there's nothing left to combine with that. So we'll have x squared on this side. Then I have a minus x and an x here, so when I bring this over, it'll be negative x minus x, so I'll have minus 2x on the left. And then finally we want to put minus 5 and minus 2 together, so when I bring this over, it will be minus 5 plus 2, so we have minus 3 equals 0. So this cubic equation ended up being a quadratic equation, which is good for us because it's less work now to factor. So I have this quadratic equation. We'll try to factor it instead of using the quadratic formula, but if you can't factor, use the quadratic formula and that'll give you the same answer. It's a simple trinomial. My product is -3 and my sum is -2. So our two numbers here are going to be -3 and +1. So I can factor it now like this. And from this, we see that our solutions are going to be x equals 3 from this factor and x equals -1 from this factor. But let's not forget to go back and compare these two solutions with the restrictions that we had from the very beginning. So here we had said that x can't be equal to positive or -1, but we got -1 as one of our solutions. So the +3 can stay as a solution, but this -1 has to be eliminated. So we call this an inadmissible solution or root or 0, or an extraneous root. So this means that although it came up as a solution when we factored, we know that it can't be possible because we did have these restrictions at the very beginning. So the only solution to this rational equation would be the x equals 3. So if we were to graph this, the only place where it crosses the x-axis has to be at +3. Thanks for watching. Mrs. A Loves Math.